Example 3, we're going to again use substitution. Again, if I look inside the inside function, inside the square root, its derivative will match the x squared on the outside. Okay, so it's going to account for that x squared dx on the outside. The 4 I don't really need to worry about because it's just a coefficient. So I'm going to use my substitution. U is going to be the 3 minus x cubed. Now you could just let it be negative x cubed or just x cubed and leave the constant inside the root, but it's probably easier to account for the constant and horizontal compressions and expansions in the u function. So then when I generate my du, I end up with negative 3x squared dx. Okay, so we'll just change that color there. We're just going to make that blue. And we're going to do the replacement here. So I'm going to pull the 4 on the outside. It's going to be the integral. I have my square root part, so I'm going to put my u inside the square root. The x squared dx is going to be replaced by this function here. Oops, I'm going to just do that. And so if I just rearrange this a little bit, my x squared dx, okay, is going to be du divided by negative 3. So I'm going to put the divide by negative 3 on the outside and the du in here. So there's my integral. So when I anti-differentiate this, I end up with negative 4 over 3. This u in the denominator is u to the power negative 1/2, so it becomes u to the power positive 1/2, which is just root u. Divide by 1/2 is same as multiplying by 2, so I'm going to multiply by 2 here, plus c. So then substituting back in, the square root part becomes 3 minus x cubed, and then we have our plus c. Okay, so this represents the antiderivative of our original function.